tragedies in aviation often remind us of both the marvel and fragility of modern technology. Among such events, one of the most shocking was the Air India plane crash that shook the world and raised countless questions about design, safety, and the future of air travel. Hello everyone, welcome back to the World Conflict Monitor channel, and if you haven't subscribed yet, please take a moment to subscribe and support us as we continue to bring you detailed explanations of global events, conflicts, and important stories. Today we are diving deep into the Air India plane crash explained in full detail, where we will explore not only what happened but also the design of the aircraft, its exterior and interior, performance capabilities, safety features, unique selling points, price considerations, and finally a conclusion that reflects on what lessons can be learned. To begin, let us start with a summary of the story, because whenever we talk about an aviation disaster, the first thing that comes to mind is the human loss and the series of events that led to such a catastrophic outcome. The Air India crash in question involved a commercial airliner carrying passengers on a scheduled route. Shortly before landing, under challenging weather conditions, the plane overshot the runway and broke apart, leading to a devastating loss of life. Survivors recalled the terrifying moments of impact, the smoke, the cries of panic, and the heroic attempts by some passengers and crew to escape. Investigations pointed toward multiple contributing factors including weather, pilot decisions, and runway conditions, but to truly understand the crash, we must look deeper into the aircraft itself. This story is not just about one accident but about how every feature of a plane, from its exterior to its interior, from its engines to its safety systems, plays a vital role in the survival of its passengers. From the outside, the exterior design of the aircraft is what gives it strength, aerodynamic efficiency, and the ability to withstand immense forces during flight. Air India, like many other airlines, operated modern narrow-body aircraft such as the Boeing 737 family for regional and international flights. The fuselage was crafted with lightweight yet durable aluminum alloys and composite materials, designed to endure pressurization cycles and high-speed air pressure at cruising altitudes. The wings were swept back with precision engineering, housing powerful engines underneath that provided the necessary thrust for takeoff and climb. The landing gear was retractable and built to absorb the shock of landings on even shorter runways, while the tail fin and horizontal stabilizers gave the aircraft balance and stability. In terms of livery, the Air India planes stood out with their signature white fuselage, red tail, and the iconic Maharaja-inspired branding, a symbol that represented national pride. But beyond the look, the exterior was an engineering marvel, designed to carry more than 180 passengers at a time across thousands of kilometers safely and efficiently. When we move inside, the interior design of the Air India aircraft was focused on balancing comfort with capacity. The interior was configured with an economy-class layout, rows of seats fitted with fabric upholstery, tray tables, overhead bins for carry-on luggage, and in some cases, an upgraded business class section with more legroom and wider seats. Lighting was functional, and air conditioning vents provided circulation for passengers. The cockpit, located at the front, was compact but filled with advanced avionics, digital displays, and communication systems. While the interior did not have the luxury of long-haul wide-body jets, it was functional, practical, and designed to move large numbers of passengers quickly and affordably. This simplicity is one reason why such aircraft became the backbone of fleets across Asia. Performance is where the aircraft truly stood out. Equipped with twin turbofan engines, the Air India plane had the power to cruise at speeds above 800 km per hour in altitudes of 35,000 feet. The engines were optimized for fuel efficiency, giving the airline better economics while still allowing for long-distance regional flights. The performance of the aircraft in terms of climb rate, stability, and maneuverability was generally considered reliable, and this is one reason why it was one of the most widely used aircraft models in the world. However, in challenging conditions such as heavy rainfall, crosswinds, or short runways, even the best-performing aircraft can be vulnerable if all operational procedures are not followed with precision. The unfortunate crash highlighted how performance is not only a matter of technology but also of coordination between pilots, weather, and airport infrastructure. Safety features are perhaps the most critical aspect of any commercial aircraft, and in this case, the plane was fitted with multiple systems designed to protect passengers and crew. These included reinforced landing gear to handle rough landings, advanced avionics to assist pilots in navigation, ground proximity warning systems to alert when the plane is too close to terrain, and redundant hydraulic systems to ensure control surfaces function even if one system fails. The cabin was equipped with oxygen masks for emergency depressurization, life jackets under each seat, and emergency exits with inflatable slides for quick evacuation. Fire suppression systems in the cargo hold and engine nacelles added another layer of protection. Despite all these safety measures, accidents can still occur when human factors, environmental challenges, or unexpected technical issues come into play. What the Air India crash reminded us is that safety in aviation is a continuous process of learning, upgrading, and never underestimating risks.